Hello children, I hope you all are well. Today again we are going to continue same chapter, that is chapter 2, Motion, Part 2. Now children, as I have already explained you about motion and rest and how motion is relative. Now we are going to discuss next topic, that is types of motion. So children, when you look around your surroundings, what do you find? You find that different objects are in motion? Yes or not? Yes. You will find that some objects are moving on a straight road, some are rotating, okay, some are rolling, yes or no? So you find different types of motions. So here also we are going to study types of motion. Now the very first type is your translatory motion. Now what is translatory motion? If an object moves in such a way that every part of the object moves through the same distance in same time interval, then the object is said to be in translatory motion. In simple words, the whole object moves at the same time in the same direction. So basically children, what is translatory motion? Means when whole object, you can say that when whole object or all the parts of the object moves through the same distance in same time interval. Okay, suppose you are standing here and after some time you want to reach here. So what will happen? You will whole move from this point to this or not? Means the whole part of your body will move through the same distance in same time interval. Okay, whole part, or you can say that every part of the object moves through the same distance in same time interval. Okay, and this is your translatory motion. Okay, that it means that every, suppose this there is 2 point A and B. So what is translatory motion? Suppose any object is at point A and object which is at point A want to reach at point B. So when it will move to point B or when it will move towards point B, so it means that all the parts of the body of this object will move from point A to point B and it will cover same distance in same times, in same time. Okay, means your every part of the object moves through the same distance. It does not mean that some part of your body will left here and after some time it will move. No, it means that all the parts of the body will move through the same distance in same time, and this is known as your translatory motion. Okay. Now translatory motion, basically it is of two types, that is your rectilinear motion and curvilinear motion. Now what is rectilinear motion? When an object moves along a straight line path is said to have a rectilinear motion. Rectilinear motion means that when a body as a whole moves along a straight line path, when a body, suppose this is body A, so when it moves along a straight line path or any body moving along a straight path, then that body is said to be having which motion? Rectilinear motion. Okay. Now here a few examples are given. The car moving on a straight road. Okay. A snooker ball moving in a straight line on being hit are in a rectilinear motion, or an apple falling from a tree is also an example of rectilinear motion. So basically what is rectilinear motion? When an object moves along a straight line path. Okay, when an object moves along a straight line path, then that object is said to have which motion? Rectilinear motion. Now the another part of translatory motion is your curvilinear motion. Now as rectilinear motion means when an object moves along a straight line path. Okay, similarly what is curvilinear motion? When an object moving on a curved path is said to have a curvilinear motion. Suppose there is a curved path, okay, and your car is moving over a curved path. So now the car is having which motion? Curvilinear motion. Okay, means when an object moves along a curved path, then the motion is said to be as curvilinear motion. Now few examples are given. A cyclist racing on the curved track of a velodrome is a curvilinear motion. The earth moving around the sun. Okay, earth moving around the sun. It is also a curvilinear motion. Yes or no, children? Because it is moving along a curved path. Okay, a car taking a turn on the road. You all know that suppose this is a one road, this is another road. And if the car has to take the turn from this road to this road, okay, so it will move along a curved path or not? Yes. So here also this car is traveling along a curved path, and hence it is having which motion? Curvilinear motion. Okay, a ball thrown upwards at an angle. Suppose a boy is standing here, okay, and he is throwing ball upward at an angle. So if the ball is thrown like this, so this ball is also covering which path? Curved path. So it means the ball is also having, the motion of the ball is also a curvilinear motion. Another example is given here. Throwing of a javelin are some more examples of curvilinear motion. So translatory motion is having two parts, rectilinear motion and curvilinear motion. When an object moves along a straight line path, then the object possesses rectilinear motion, and when an object moves along a curved path, then object possesses curvilinear motion. So I hope, children, it is clear to you. Now, circular motion. Circular motion is a special case of curvilinear motion. Okay, children? Circular motion is nothing but it is a special case of curvilinear motion where an object moves around a fixed point in a circular or closed path. Okay. So circular motion is a special case of curvilinear motion where what happens? Where object moves around a fixed point in a circular closed path. You can see here. Suppose this is fixed point. Suppose this is fixed point O. So if an object moves around a fixed point in a closed curved path, closed curved or closed circular path, closed path, okay, then the object is said to have circular motion. In this case, the distance of the object from the fixed point always remains the same. Okay, so how does the distance of the object from the fixed point always remains the same? Suppose, children, here is any fixed point, okay, and you connected any rod like this, okay, from this fixed point, and now you are moving this, you are applying force here and you are moving this rod around a fixed point. Okay, this is your fixed point, this is your fixed point, okay, and you are moving this rod along this fixed point. So what is happening here? The rod, the distance, this end of the rod, which is A, the end of the rod A will remain at the same distance from the fixed point. Yes or no? Yes. Okay, like here, see, circular motion. Here object is moving along a fixed point. Yes, like this. So what you are finding here? First of all, circular motion mein this path is closed. Okay. Secondly, the object is at fixed, will always remain at the fixed distance from the fixed point. This is your fixed point. This point, black dot, is your fixed point. So when this object will move along this circular path or move along this fixed point, it will always remain at the fixed distance. Means, suppose this is your fixed point and any object is here which is moving along suppose this object is moving along this fixed point. Okay. So the distance of this object, the distance of this object will always remain same from the fixed point. Suppose here its distance from this fixed point O is 5. So when the object will come here, here also the distance will remain same, that is 5. Here also, when the object will come here also the distance from the fixed point O will always remain same, that is phi. Means the distance of the moving object along a circular path always from the fixed point always remains same. So there is a slight difference between curvilinear motion and circular motion. Circular motion is a special case of a curvilinear motion, okay, where the object moves around a fixed point in a closed circular path, and in this case the distance of the object from the fixed point always remains same. Some more examples are given in your book. The motion of the child sitting on a merry-go-round. Merry-go-round you must have seen in your schools, okay. So what has happened in merry-go-round? In merry-go-round there is a fixed rod in the center and the three holders are like this, okay, and you stand over this and it starts rotating. So what is happening? The distance, there is a fixed distance at every point, okay. Or a giant wheel you must have seen, okay. So in giant wheel also, suppose this is a fixed point and from this fixed point this distance always remains same, okay. An object moves along a close, or that you are sitting here, so this object moves along a closed circular path at a fixed distance from the fixed point. That fixed point is at center, okay. So I hope children I am clear to you, okay. Now your next is your rotatory motion. When an object rotates or spins about an axis, called the axis of rotation, it is said to be in rotatory motion. Now what is axis, children? Axis is an imaginary line through about which an object rotates. Means that object rotates about that line only, okay. It rotates, suppose this is your axis, so axis is an imaginary line. So if any object is moving or rotating, so it will rotate or move along that fixed axis only, okay. Like here the example is given, okay. Moving or spinning top, the top has this spinning top has also this imaginary line or axis about which this object rotates, and the motion is said to be as a rotatory motion. So when an object rotates or spins about an axis, what is your axis, children? Axis is your imaginary line which passes through the center of the object, okay, and about which the object rotates. So in rotatory motion, all the parts of the object do not move through the same distance in same time. The part away from the axis moves through the greater distance than the part near the axis. So means, suppose this is the axis, imaginary line about which the object is rotating or moving or spinning around this axis. Excuse me. So the part away from the axis means this part, that is the outer part, it will cover more distance, or it will move through greater distance than the part near the axis, okay. Now few more examples of rotatory motion is your moving fan. Like this is your moving fan. So in moving fan also there is an imaginary line that is known as your, suppose this is your moving fan. So in moving fan also there is an imaginary line that is called your axis about which this fan rotates, okay. And this, as this line I am telling you, the part away from the axis, like this blades of the fans are away from the axis, so they will cover more distance as compared to the center part. Center part will rotate here only, so it is not covering much distance, but as you move away from the axis of rotation, the object will cover more distance, okay. I hope children this line is clear to you. I am explaining you this line. The part away from the axis moves through the greater distance than the part near the axis. And the very good example is of your fan, that is your ceiling fan or moving fan. What do you find in fan? Fan has your blades also, okay. And suppose the axis of rotation, or the imaginary line passes through the center here. So as you move away from the axis line, the object will cover more distance. You can see it is covering much larger circle as compared to this part. This will cover only this small circle. Okay, so I hope children this is clear to you. And few more examples are given, like you're moving of the wheel of a moving car. It is also covering a rotatory motion. It is rotating about its axis, spinning top, moving fan, etc. Okay. Now, next motion is your oscillatory motion. Now, what is oscillatory motion, children? When an object as a whole moves to and fro about its mean position, it is said to be in oscillatory motion. When an object as a whole moves to and fro about its mean position, it is said to be in oscillatory motion. What is to and fro motion, children? Like motion of the pendulum of a wall clock. Okay, pendulum of a wall clock is somewhat like this. Yes, suppose this is your wall clock, 12, 6, 3, 9. So this is the pendulum of the wall clock. So the motion of the or the swinging of the pendulum of a wall clock, they all are your oscillatory motion. And how does the oscillatory motion occurs? It moves in oscillatory motion. The object moves in a to and fro motion. What is to and fro motion? This is your to and fro motion. I am making this here. Suppose this is this object is at rest. When the object is at rest, that is called your mean position. Okay, when the object is at rest, then that is called your mean position. Then after some time, when the object will start moving to and fro, it will come here. Then again it will go to here, and again it will come at the center. So the center point is called your mean position, and these two ends are known as your extreme positions. Okay, these two ends are known as your extreme position. So what is your to and fro motion, children? To and fro motion, the center or the point where the object takes rest, that is called your mean position. Okay, and suppose you are hitting the pendulum is here. Suppose initially the pendulum is at rest. So that resting position of the pendulum is your mean position. Now as you hit the pendulum of the wall clock, it will move to this side. Okay, and then again it will move to this side. It will go here, then it will come back to mean, and then again it will go to this end, and again it will come back to mean. So it is somewhat like this, to and fro motion. First of all, the object is at mean position, then it will move to extreme. This is your mean position, then extreme position, then again it will go to extreme position, and then again it will come to mean position. So this is known as your to and fro motion. Okay, so again I am making this diagram. What is your to and fro motion? Like this, mean position, then extreme position, then again going back to extreme position, and then again coming back to mean position. And this is your to and fro motion. And children, the pendulum of a wall clock, this is the pendulum of a wall clock. It also moves in a to and fro motion. Means suppose initially when the pendulum is at rest, it is your mean position. Then as it moves, it will go to extreme. Then again it will move to extreme, and then again it will come back to mean position. And this way the pendulum of the wall clock will move like this, to and fro motion. This is known as your to and fro motion or back and forth motion. Either to and fro motion we say, or back and forth motion. Okay, so I suppose children to and fro motion is clear to you. To and fro motion is like this. Suppose initially the object is at rest, that is known as your mean position. When it will move to this end, this is called your extreme position, and from here again it will move to another extreme position like this, and then again it will come back to mean position. So this is known as your to and fro motion. The swinging of a pendulum clock, or the swing in motion. Swing in motion is also a moving swing is also a oscillatory motion. Means here also, suppose the boy is sitting on a swing. So swing, boy is sitting here, children. Okay, so swing also moves, or swing also covers oscillatory motion. How? सबसे पहले the swing is at rest. Okay, now what will happen? Somebody hits here, so the swing will move here. Then again, initially when the swing was at rest, it was the mean position. After hitting, it will go here. Then again, it will go back, and then again it will come to the mean position. That is why the example is given here. This moving swing is an example of oscillatory motion. And in children, oscillatory motion, the body as a whole move. Okay, it's like suppose this boy is swinging. Okay, boy is swinging. Okay, so means the whole part of the body is swinging. Like suppose this is swing. Okay, so first of all, when the swing is at rest, that is your mean position. MEAN, mean position. Then after hitting, the body will go to this end, that is your extreme position. Again it will go to extreme position, and then again it will come back to mean position. Then again it will go to extreme, and then mean. Okay, like this. Mean, extreme, like your swing is there, initially at rest, your swing, it will go, after hitting it will go to extreme, then again it will go back extreme, then again it will come to mean, then again it will go back to extreme, then again it will go to another extreme, and then again it will come to mean. So this kind of motion is known as your oscillatory motion. And in oscillatory motion, children, your body as a whole moves. Okay? Okay, children. Now, vibratory motion. Vibratory motion, if the body does not move to and fro as a single unit, but some parts of a body oscillate about their mean position, is known as vibratory motion. Now children, in vibratory motion, the whole part of the body does not move, only some part of the body move. Now this I will explain you through an example. Suppose you are holding a rubber band, you are stretching a rubber band between your two fingers like this, and you pluck the rubber band like this. So what will happen? The rubber band will move up and down. Okay, only some part, not whole part of the rubber band will move. Just see, here the tuning fork is given here. So rubber band will vibrate like this, or when you pluck the that strings of the guitar. Suppose these are the strings of the guitar, and when you pluck the strings of the guitar, they start vibrating or not? So not all the string starts vibrating, only some parts of the strings or the part of the string starts vibrating. Okay, so in vibratory motion, it is a special case of oscillatory motion. Vibratory motion is a special case of oscillatory motion, in which not whole part of the body moves, but only some of its part oscillate. Oscillate means they only start vibrating. You know the vibration. You can understand this thing when you take a rubber band and stretch between your fingers and start plucking the rubber band. So it will produce a sort of sound also, and it will start vibrating. Okay, so that you see with your practical method also. I am telling you how you can do this. Okay, and one more example is given here. Tuning fork. Okay, here. Tuning fork. This is your tuning fork. So when this tuning fork is hit to something, it starts vibrating. You can see here vibration. So not whole this part is moving. Only some part starts oscillating. Okay, kuch part, not whole, as it does not move as a whole. Like this, when you stretch, these are the strings of the guitar. When you pluck the strings of the guitar, so not all the string moves. Only some part of the string starts vibrating, and that is known as your vibratory motion. So I hope children, I am clear to you. Okay, and if you have any doubt, you can clear your doubt by asking questions in comment section. Okay, and I will take your doubt in next lecture. So thank you class, and revise all the topic.